Hi everyone, Phil Conrad here, and here is a more detailed look at the CCS Computing faculty for this year and the courses we are teaching that are open to CCS students that are not computing majors. First of all, I'm Phil Conrad. I'm a teaching professor in CCS Computing, and I also teach in the College of Engineering Computer Science Department, and I'd like to introduce my two colleagues. First, Murat Kara-Orman.
Hi everybody, I will be in fall, I will be teaching a class on blockchain. And blockchains are the decentralized distributed ledgers used for recording transactions, typically for cryptocurrencies like Bitcoin, Ethereum's ETH, as well as many other applications. In this class, we'll be covering the mostly the theory from
Actually, Murat, sorry to time you. I think what we want to do is
introductions first.
Just introduce ourselves, and then what I was going to do is go to the slide with the courses, and go through like so the stuff you were saying is all good stuff, but I think we want to do that when. And sorry, let me get that slide up again. I lost it.
So basically, we're going to introduce ourselves as if they didn't see the previous one.
That's right. That's right.
Okay,
probably not as rushed.
Great.
Yeah, like not as rushed this time. Let me get that slide
and
up.
Here,
that's the slide I was looking for. Yeah. So the idea, yeah, you can take.
Yeah, but I mean, yeah, well, I'll keep it short and sweet.
Yeah, but you can take as long as you need. But I just wanted to. I think before we get into the courses, I wanted to just have this up. So let's start that again. I think we're rolling, right? Let me stop sharing. And yeah, we're rolling. Richard, are you still there? I think we lost Richard. Oh, is he back? Okay, they're back. All right, so let's start it again. Here we go. 3, 2. Hi, I'm Phil Conrad, and we're back with the CCS Computing faculty, and we're going to introduce ourselves, and then we're going to introduce the courses we're teaching this year that are open to CCS students that are not computer science majors, and if room is available to non-CCS students that are not computer science majors as well. So first of all, I'm Phil Conrad. I'm a teaching professor in both CCS Computing and the College of Engineering Computer Science. I've been here at UCSB for about 13 years now. And I'd like to now introduce my two colleagues. First, Murat Kara-Orman.
Hi, everybody. This is Murat Kara-Orman. I'm a computer science faculty at CCS, half-time appointment for the past 20 years. While simultaneously, I also have a deep practice in the software industry, spanning embedded software space, as well as entrepreneurial in the cloud and distributed system space. So I try to bring in my expertise and experiences largely from what I do actually outside of the industry. So I'll be teaching 2 classes this year with that focus. The first one will be offered in fall. It's on blockchains, and blockchains are the distributed ledgers. They're decentralized, and they're used to record transactions involving.
Okay, Murat, sorry, I guess I didn't make it clear. What I'm hoping is that you will wait to talk about the courses until all 3 of us have introduced ourselves and we're looking at the course schedule.
Sorry about that.
Yeah, it's okay. So let's try it one more time. Here we go.
This works.
3, 2. Hi, everyone. I'm Phil Conrad, and I'm here with the CCS Computing faculty to do a brief rundown of introducing each of us and then introducing the courses that we're teaching this year. So my name is Phil Conrad, and I'm a teaching professor in the College of Engineering Computer Science Department, as well as the program chair for CCS Computing. And my two colleagues, Murat and Richard, will each introduce themselves. First Murat, and then Richard, and then we'll go over all the courses that we're offering this year. So Murat, take it away.
Hi, everybody. This is Murat Kara-Orman. I have been teaching for the past 20 years as a continuing lecturer, continuously, without interruption, while simultaneously working in the software industry, as well as entrepreneurially having launched a startup. So I bring my experiences from the industry largely to the classroom. to Richard, I think.
Hello, everyone. My name is Richard Wang, and I am a teaching professor in CCS Computing, as well as the College of Engineering and Computer Science. My background kind of varies. I've worked in software industry for Amazon. I've been in research and development. I've been in academia and teaching. So I have a lot of experience, a very broad range. So if you ever have any questions about career paths, I'll be happy to talk to you about that. And in general, I'm kind of the rookie of the group, and this is my 4th year here at UC Santa Barbara, but my 7th year teaching. So, you know, and back to Phil.
All right, great. Well, let's take a look at the courses that we have on tap for this year. This is not a complete list of courses. Some of the courses we're teaching are just for the CCS computing majors, but these are the ones that are open to CCS students that are non-majors in computing, as well as, when space is available, students from outside of CCS. So let's start with fall. And Murat, can you tell us a little bit about Foundations of Blockchain?
Thank you. Well, this class is about blockchains, which are the really the most common used name for distributed ledgers, heavily used for recording transactions made with cryptocurrencies like Bitcoin, Ethereum, as well as many other applications. In this class, we'll cover the underlying theory from distributed systems and crypto research, as well as practical tools, techniques, languages for building blockchains, and some applications.
And Murat, what kind of prior programming experience would students need for a blockchain?
I would like as much experience as possible, but even if you're not experienced, just to learn about these kind of hot topics, I welcome you to come audit the class. Easier using Zoom to have more people just auditing. But really, there will be guest speakers from the industry, as well as tools and techniques. So I would like it to be very much hands-on, project-based. So it'll be taught in the style of a graduate research seminar with more hands-on focus.
All right, great. And if you'd like to know more, you can contact Murat. You can find all the information about all of us at the CCS website. And this website here, which is probably the one that you already went to get this video. So let's move on to winter. In winter, we have 2 courses, computer science for non-majors, which I'll be teaching, and then game design for non-majors, which will be taught by Richard. Both of these courses do not require any prior programming experience. So these are great if you want to learn about programming and computing. Computer science for non-majors is essentially a version of the College of Engineering's CS8 course, in which we teach basic Python programming, but adapted for the CCS style of teaching. So instead of a lecture hall of 120 or 180 students, you'll be in a Zoom room, I guess, since we'll probably still be doing Zoom in winter, with just 8 to 12 students. And the idea here is to learn basics of Python programming, hopefully enough that then you can apply that to whatever your major interest is, or whatever your interest is outside of your major. So if you're a chemistry major, hopefully after learning some basic Python programming, you'll be able to apply Python programming to chemistry. Or if, regardless of your major, you happen to have a real interest in Pokemon, you'll be able to design some piece of Python software that deals with Pokemon. Whatever it is that is your interest, we'll learn the basics of programming and then be able to apply that to your area of interest. That course will also be taught again in spring by Murat. And there's a follow-on course, the second course, if you take the first quarter of this, or if you've already had some programming background, there's Computer Science for Non-Majors second course taught in spring, and Richard will say a little bit about that in a minute. First of all, let me throw it to Richard. Can you tell us a little bit about the Game Design for Non-Majors course that you're teaching in winter?
Sure. So game design and computer science, and as well as many other fields, go hand in hand. I mean, game design in general is an interdisciplinary effort that consists of artists, musicians, audio engineers, physicists, mathematicians, you name it. There's a lot of subjects that are involved in game design. So this is an opportunity to really focus on game design principles, but at the same time still learn how to design and create your own games. So there's going to be some computational elements. You'll be learning a little bit about how to write some programs to actually design and build your own games. And generally we do this a few games per course. And one of the big projects at the end is working in interdisciplinary teams where you can really focus on your interests. It could be, music, writing, or anything that, you desire to really dive deep and really apply that into actually creating a game in an interdisciplinary team. So no programming experience is required for this course. And the course itself will really focus on game design principles and allow you to really dive deep and actually build games.
All right, great. That leads us to spring, where we have 4 courses. One that is open to folks with no prior programming experience, taught by Marat, and then 3 that do require some prior programming experience. Marat, do you want to say anything more about the computer science for non-majors course for spring?
No, I think you covered that.
Okay, great. So let's then come back to Richard. So if you have already taken the computer science for non-majors course, either in winter 21 or in any prior quarter, or if you already have some computer science background, let's say maybe AP Java from high school, or you've just done some programming on your own, then you might want to look at this computer science for non-majors second course taught by Richard. So Richard, you want to say a little bit about that course?
Sure. So this course is actually built upon the first quarter of the series, which is going to focus on Python. So in this course, the focus will be on Python. So some programming experience is required, but at the same time, if you don't have a Python background, you may have to play a little bit of catch up in order to, go through the course because all the material will be Python based. But the purpose of this course is really to focus on computer science fundamentals, data structures, how do we store data, how do we maintain it, how do we access it, and also how do we actually measure performance? How are we going to make our algorithms more effective, and really kind of start thinking like a computer scientist, and the ideas of performance is going to be introduced, as well as best practices. How do you test software properly? How do you work in groups with software engineering? There's going to be elements of that. And in general, in the spirit of CCS, one of the goals is for, as Phil was saying, once you take this first quarter, you can start applying it into your interest. This course would actually also allow you to pick a project that you yourself want to really work on and apply all the computer science principles that you learn in this course and in the previous course into something that you're passionate about.
All right, well that brings us to the next course, digital audio. So this is a course that I've taught before a couple times, and in this course we look at the mathematics and the computer science behind digital audio synthesis. So if you have an electronic keyboard that makes piano sounds and trumpet sounds and guitar sounds, what is actually going on? That really is a computer that just has, instead of having a screen, it has speakers, and instead of having a QWERTY keyboard with letters and numbers on it, it has a piano-style keyboard. But inside, it's still a computer. So let's find out, what does that software look like? How do you write software to produce different kinds of sounds? That gets us into different synthesis techniques. We can also look at analysis techniques. So how do we apply the Fourier transform to a signal and begin to analyze sound waves in terms of concepts such as pitch and rhythm and meter. So if you are interested in the phenomenon of sound and music and how that relates to computing, this is a course that might appeal to you. It is helpful to have a programming background for this course, as well as some mathematics. We will be talking about the Fourier transform, so at least the first semester of calculus is something you probably want to be at least familiar with in a vague passing way. If you don't remember how to actually do integration by parts, that's not a problem, but you should at least know, what's an integral and what's a derivative. That is the digital audio course. And let's hand it off to Murat to talk about computing for the cloud and Internet of Things.
Hi, everybody. Well, this is an area of some expertise for me. IoT, first of all, is the Internet of Things. These are connected things, connected to probably each other, or at least to some owner controller. And the experience I bring comes from actually having being the tech lead and a designer and implementer of Texas Instruments IoT SD software development kit, compliant with Apple's HomeKit, which was an intense effort that I left behind when I moved from TI to analog devices. But I still have the understanding, core concepts and everything, as well as I started looking at Amazon AWS IoT specifications and infrastructure. They're rather diverse. The two are very orthogonal. They're very different logic to building IoT things. But there's a deep underlying data communications, networking, and cloud computing aspects to all of these. And I will be covering those. If you don't have to have a background on everything, we'll basically teach you as much as you need to know, kind of intro. And then the goal is actually dive deep into really the nowadays standardized industry standards on IoT. And one of the things I want to add to it is how cloud and IoT comes here is I would like to promote the term IoT to smart things, which means you can do additional things on the cloud that will give us actually behavior that is also learned, and there's machine learning elements to what can actually sit behind these things. So they're not just your light bulb that you control by turning it on and off, but they can have some semi-autonomous behavior that they learn as well. So it's pretty exciting actually to go in that direction. And ideally, the attendees of this course will be building things, whether they're physical hardware devices or there's software emulations. We'll teach you the ropes. There's a lot of infrastructure already built, so we can do these things. It's very exciting.
All right. Well, thank you, Murat, and thank you, Richard, for helping me to introduce all of our students to the many exciting possibilities about learning about computing this year. And to all the students watching this, thanks for watching. And we hope to see you probably online. And we look forward to a time when we can once again see each other in person. So thank you, and best of luck for 2020, 2021. Bye-bye, everybody.
Bye, everybody.